I am Anil Kumar. Welcome to my series on calculus. We are discussing questions related to related rates. Here is a very good application question from my worksheet, question number 7. Consider motion of a particle along the path 2y equals to x cube minus 4. Find the points on the curve at which the y coordinate is changing 6 times as fast as the x coordinate. You can always pause the video, answer the question, and then look into my suggestions. So let's try to understand. We are given this function, which is 2y equals to x cube minus 4. Now we're saying, find the points on the curve, there could be more than one, at which y coordinate is changing 6 times as fast as x coordinate. So when we talk about changing, we're saying changing with respect to time, because the particle is moving with respect to time, right? So y coordinate is changing 6 times as fast, means we are given that dy dt is equals to 6 times dx dt. Is that clear to you? Now that is a key to solve this question. Perfect. Once you understand this, the solution is very simple, right? So now let's figure this out. So once we know that, we'll begin with 2y equals to x cube minus 4. We can differentiate both sides with respect to time, right? So if you do that, we get 2 dy dt equals to 3x squared dx dt. Derivative of 4 is 0. Now, we know that dy dt is 6 times dx dt, so we get 2 times 6 dx dt, correct? Let's put bracket here, equals to 3x squared dx dt, clear? So we replace dy dt with 6 dx dt from here. Is it clear to you? And now we can actually cancel dx dt and we can find the value of x. So we have here 12 equals to 3x squared. So x squared is 12 by 3, which is equal to 4. And clearly plus minus 2. We get two values for x. Correct? So we know the two values of x. Now we need to find the points, right? Find points. So to find the points, we'll substitute the value of x in our equation and then find the points, right? So we have the equation 2y equals to x cube minus 4. We have y equals to half of x cube minus 2. So if I substitute 2 here, we get y equals to half of 2 minus 2, which is minus 1. So that is 1 point. So we get a point which is for 2, it is minus 1. And now we'll substitute minus 2. So y equals to half of minus 2 minus 2, right? So that is minus 1. That gives me minus 3. So the other point here is minus 2 minus 3. Is that clear to you? So we can now write down our answer that the 2 points are 2 minus 1 and minus 2 minus 3. Is that clear to you? So that is how you can actually solve this question. So I hope you find it interesting and useful. Now here is question number 8, which is a kite is 80 meters high and 100 meter of string is out. If the kite is moving away horizontally at the rate of 32 meters per second, find the rate at which the string is being pulled out. So think about it like this. Vertically, the kite is 80 meters high, right? So this is 80 meters. This is fixed. Now, the kite is moving away like this in this direction, right? Moving away horizontally, and this rate at which it is moving away, let's say dx dt, is equal to 32 meters per second, correct? And find the rate at which the string is being pulled out. So the string, you're holding the string somewhere here, for example, is 80 meters. So let's say like this. Okay. So that becomes 80 meters. So let this be y for you. So that is the situation. Perfect. So definitely that is at right angles. Now, looking into the situation clearly, we can say that x and y are related with the Pythagorean theorem right there, correct? So let's write down what we have. So we know that rate of change dx dt along horizontal is equal to 32 meters per second, right? And what we need to find is dy dt when the kite is 80 meters high and 100 meters of string is out. So when y is equal to 100. That is what we need to find, right? Now, to find this, we can relate, and we know what is y square equals to. Y square is equals to 80 square minus x, y square is the hypotenuse, is 80 square plus x square, right? So now differentiating with respect to time, we get 2y dy dt equals to, rate of change is 0 for this, right, plus 2x dx dt. So at this stage, we differentiate with respect to time and we get this result. We need to find what dy dt is. So dy dt is basically equal to 2x over 2y times dx dt. That's what it is. Now, of course, 2 and 2 will cancel. So we get our relation dy dt is x over y times dx dt. Now, in this relation, we have x also, right? Do you see that? But we know what y is. We have to figure out what x should be. So to find x, we'll have to use this relation and find what is x when y is 80, correct? That is the whole idea. So what we get here is we need to find what x is. So we'll work it out. So we know y is 100. So we have 100 square equals to, let's say, 80 square plus x square, right? So x square is equals to 100 minus 64, 100. And, x will be square root of this, which you know from your theorem 3, 4, 5, and this is 6, 8, and 10, right? So you get your result. So we are expecting 6 here, right? So we get x equals to 6 from this 60 rather, from the triangle. Let's do it. So we have here, let's use 100 minus 6400, correct? So we have 100 minus 6400 equals to, which is 3600, and we'll do square root of our answer to get 60. Perfect. So these values are taken so that you could easily solve, right? So we get 60 meters. That is the value of x. So basically, when we say find the rate at which the string is being pulled out, now that was when the string was 100 meter long. So x value is 60. So we'll put 60 here. So we can write down the rate as dy dt when y equals to 100. That means x is 60 will be, so substitute 60 for x and 100 for y, and rate of change is 32. Correct? So that gives you the answer. Right? So you can multiply by 2. 6 times 2 is 12, 2, 1. 6 times 3, 18, 19.2. And the units are meters per second. Is that clear to you? So that is how you could actually answer this question. I hope the steps are absolutely clear to you. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.